Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we take a look at addition, subtraction, multiplication, and division of complex numbers. So, suppose we have an example where we have two complex numbers and we want to add them. Well, basically, what we're going to do is we're going to add the real parts and we're going to add the imaginary parts. So, you can think about it as combining like terms. Even though I is not a variable, we can treat it as such. So we have negative 3 plus 4, which is 1, and we have negative 4i minus I, which is negative 5i. So our number is 1 minus 5i. So here we can treat this as I said, as if they're polynomials, even though they're not. We have negative 6 plus 5i. Then we want to subtract what's in parentheses, which means we're going to have to distribute. So when I distribute the negative across negative 4 minus 11i, it becomes plus 4 and plus 11i. So again, we can add our like terms. Negative 6 and 4 is negative 2. And 5 plus 11 is 16i. Now, when we multiply two complex numbers, it's the same. It's the same as if you're multiplying polynomials, but we have to remember I squared equals negative 1. So when we go in and we use 4, we have 8 minus 3i times 2 plus 5i. 8 times 2 is 16. We have 8 times 5 is 40i. Then we have minus a 6i is negative 34i. And then we have minus 15i squared. Remember, I squared is negative 1. It's going to make this positive 15. And 15 plus 16 is 31. And we have our minus 34i. So, we've talked about adding, subtracting, multiplying. In order to talk about division of complex numbers, we need to talk about the conjugate of a complex number. So, the complex conjugate of the number a plus bi is a minus bi, and vice versa. So, to find the conjugate of a complex number, you are going to change the operation in front of the imaginary part. So, we change from plus to minus. Now, what is that going to do for us? Well, if you multiply a complex number by its complex conjugate, then what you get is a squared plus b squared, and your i's go away. Now, why is this important with division of complex numbers? Well, in order for a complex number to be in simplest form, we need it in the form a plus bi. And in a plus bi, we don't have any i's in the denominator. So that's why we need the complex conjugate number so that we can divide. So let's do an example where we're multiplying two complex conjugates. So the formula that we have here is a plus bi times a minus bi is a squared plus b squared. Now you can use FOIL and you will get to that. So we're going to do it the long way. We're going to use FOIL. 3 times 3 is 9. We have plus 6i minus 6i. That goes away. And we have minus 2i times 2i is 4i squared. Well, knowing that I squared is negative 1, it makes this positive 4. So 9 plus 4 is 13. So how do we put this with division? Suppose we have a complex number 3 divided by 4 plus I. And we know that this is not in the standard form for a complex number because that I is in the denominator. Well, what we do is we find the complex conjugate of the denominator. So the complex conjugate of 4 plus I is 4 minus I. And remember, whatever you do to the denominator, you must do to the numerator. So what we have done is we have put in a funny looking 1. 4 minus I divided by 4 minus I is 1. So in our numerator, this is going to equate to the distributive property. We have 12 minus 3I. In our denominator, remember we had a plus bi times a minus bi was a squared. So 4 squared is 16 plus our b squared. Here b is 1. B squared is 1. So we have a denominator of 17. Remember that we have to break this up to be in the true a plus bi form. So this is 12 over 17 minus 3 over 17i. So that's division of complex numbers. Let's look at another one. Suppose we have 3 minus 4i divided by 4 plus 3i. So remember, we're trying to get rid of the I in the denominator, and that's the complex number we're going to take the conjugate of. So this becomes 4 minus 3I. Okay, so let's not get confused. You're finding the complex conjugate of the complex number in the denominator. So we need to use FOIL in both denominator and numerator. So we have 3 times 4, which is 12. We have negative 9i minus 16i is minus 25i. We have negative 4i times negative 3i. That's negative 12, positive 12i squared. And in our denominator, we're going to have a squared, 16, plus our b squared, which is 9. So let's see what we have. We're going to have 12i squared makes negative 12, and 12 minus 12 is 0. So those terms will cancel out. We're going to have negative 25i over 25, which is just negative I. So remember that Dr. LB is always in. Please come back for more math help.